The topic for the day is using the laws of exponents to multiply monomials. And in the boxes on the right-hand side of our page, on page 13 of our notes, are the basic laws of exponents. The examples on the left-hand side are examples that where we're going to use the laws of exponents. So first of all, our first law of exponents is right here. X to the a times x to the b is x to the a plus b. And this is called the product rule. All right, the way that this works is if we have x to the fifth times x to the third, this is x to the 5 plus 3 power, or x to the 8th. And what we've done here is use this product rule to multiply two monomials. Our second example here is what we call the power rule. And what this is if we have something in parentheses raised to a power on the outside, that power applies to every single thing inside the parentheses. So, for example, we have xy in parentheses raised to the third power. This is simply x to the third power, y to the third power. That part seems easy enough. The difficulty comes when we have a number times a variable in parentheses raised to a power. And the reason why is so often we forget that the power also applies to the 5. All right, so this becomes 5 squared x squared, which makes this 25 x squared. All right, the next part here, the next rule we have is also called a power rule. And I guess these are called power rules because they have a power on the outside of the parentheses. But what's different this time is we also have a power inside the parentheses. All right, what we're going to do to simplify this is multiply these two powers. And when we multiply these two powers, in this example, what we get is x to the 2 times 4 power, which is x to the 8th. Now let's look at something and see why this makes sense. If we have x squared to the 4th power, what this really is x squared times x squared times x squared times x squared. All right? And if we use the product rule to simplify this, we would have 2 plus 2 plus 2 plus 2, which is x to the 8th. Now, if we go back a minute and see why the product rule makes sense, here's why this makes sense. If we have x to the 5th times x to the 3rd, x to the 5th is this. X times x times x times x times x, 5 times. X to the 3rd is this, x times x times x. When we multiply all of these, we're counting up 8 x's, and that's why this equals x to the 8th. But there's no reason to write out all these x's. We now know that we just need to add up our x's, which is 5 of them plus 3 of them gives us 8 of them. All right, at the bottom of the page, we have rules that allow us to combine the product and the power rules. And this combination rule is here. We have x to the a, y to the b, in parentheses, raised to the n power. That means we're going to multiply the a and the n. We're going to multiply the b and the n. And what that's going to allow us to do is essentially using multiple rules at the same time. So what we're going to have in this example is x to the 3 times 4 power, y to the 5 times 4 power, which gives us x to the 12th, y to the 20th power. The example below it, remember, this power of 5, this is where people forget, it also applies to the 2. So this is 2 to the 5th, x to the 2 times 5, y to the 3 times 5. 2 to the 5th is 32. 2 times 5 is 10, so x to the 10. 3 times 5 is 15, so y to the 15th power. All right, at the bottom of the page, we have a couple of examples. The first one here, we have a negative. What's going to determine whether our answer is positive or negative is actually this power outside the parentheses. This is telling me how many times that negative is going to be multiplied. So really what's here is a -1. And since my power out here is 2, I have an even number of times that the negative will be multiplied by itself. If a negative is multiplied an even number of times, it's going to be a positive. If it's multiplied an odd number of times, it's going to be a negative. So I know right now, since my negative is going to be multiplied an even number of times, this will be a positive answer. So I can just answer positive x to the 3 times 2 power, which is x to the 6th. In my example over here, this power of 3 applies to the x, so x to the 3rd. And with the y, the power will be 2 times 3. So this equals x to the 3rd, y to the 6th. Now, in all the examples we've done so far, the exponents have been positive integers. These rules apply if our exponents are negative integers, and they apply if our exponents are fractions or even irrational numbers. No matter what kind of number the exponent is, these rules will apply. I'm just giving you basically the easy ones because these are positive integers. So let's go through some examples. Now here, I've got multiple things to do. I've got to multiply this and this and this, and that's going to take the product rule. But I also have here what we call a power of a power, which is a power inside the parentheses and a power outside the parentheses. If you have both rules, do the power rule first. So the first thing that we're going to do is this. So this will give me x times x to the 2 times 3, which is x to the 6th, times x to the 5th. And now I'm going to use the product rule. And with my product rule, I'm going to add up my exponents. Here's the mistake most commonly made, is students say, oh, I have 6 plus 5, that gives me x to the 11th. No, this is x to the 12th, and here's why. This x has a power of 1 that you don't see. So 1 plus 6 plus 5 is 12, and this will give you x to the 12th. All right, this example, we've got a power of a lot of stuff inside parentheses. So we're going to do each part of it raised to the 3rd power. So I have 3 to the 3rd power, x to the 3rd power, y to the 2 times 3 power, and z to the 3 times 3 power. 3 to the 3rd is 27, x to the 3rd power, y to the 6th power, z to the 9th power. Now, in this next example, I don't have any powers outside the parentheses. So guess what? This is the product rule. all right? Which means I'll be adding exponents. So the first thing I'm going to do is actually multiply my -3 times my 4, and I'm going to get -12. My x's, I've got 2 here and 1 right here. Don't forget that 1. You don't see the power, but it's there. So this is x to the 2 plus 1 power, and this is y to the 3 plus 2 power, gives us -12, x to the 3rd power, y to the 5th power. All right, let's go to the next one. And again, we don't have any powers outside the parentheses, so this is just the product rule. I'm going to multiply the 3 times the 4. That's going to give me 12. And I'm going to use the product rule for my x's. I have 1 here and 5 here. So x to the 1 plus 5 power gives me 12x to the 6th power. In my next example, I have no powers outside the parentheses, okay? So this negative is multiplied just once. So one negative times a positive is going to give me a negative answer. And my exponent of x's will be x to the 2 plus 4 power, which gives me negative x to the 6th power. Now, the next example to the right here has an exponent that is a variable. That's okay. Still, follow the rules. These are the examples where you know the rules. If you can apply the rule, even though it's not a number. I know what I need to do here is use the product rule, which tells me to add the exponents. That's what I'm going to do. This is x to the 2 plus k power. And I'm going to leave it just like that because I cannot simplify 2 plus k. All right, my next example, same thing except I'm going to apply the power rule here. I know that since I have a power inside the parentheses and a power outside the parentheses, I'm going to multiply my powers. The way I multiply 2 times k is 2k. So this is simply x to the 2k power. Now, my final example, I need to use my product rule for this times this. But I also have exponents outside the parentheses. When you have that, you're going to do that first. So I'm going to use my power rule first. So this is x, multiply my exponents. So this is 2 times k. And this is going to be multiplied by x to the k times 3 power, which is 3k. Now that I've simplified using the power rule, I'm going to simplify using the product rule. And the product rule tells me I'm going to add these exponents. All right? So here's my simplification. X to the 2k plus 3k power. And when I simplify that, that does simplify because 2k and 3k are like terms. 2k plus 3k equals 5k. So this is x to the 5k power.